Welcome to AI Frontiers, breakthroughs in human-machine collaboration, robust reasoning, and explainable AI. In this episode, highlights from computer science, artificial intelligence research published on December 20th, 2025 will be explored. Key topics include emergency triage, conceptual reasoning, and explainability, as well as trends in robust AI and human-machine collaboration. A deep dive into a pivotal paper on autonomous triage by Rusecki et al. Is also featured. Stay tuned for insights that are shaping the future of artificial intelligence. Imagine a scenario where artificial intelligence saves lives amid chaos. In 2025, an AI system nearly quadrupled triage accuracy during disaster simulations, achieving this without any prior training data. Picture an emergency room filled with urgency and confusion, where an AI assistant calmly guides critical decisions. This collaboration between human responders and AI demonstrates the seamless integration possible when machines and medics join forces. The question remains, what outcomes emerge when advanced AI works alongside dedicated professionals in real-world emergencies? Why does this research matter? Artificial intelligence is transforming sectors such as medicine, transportation, finance, and security. 29 recently published papers demonstrate advances in reasoning, adaptation, and transparency within AI. These works focus on collaboration, robust learning, and explainable decision-making. Whether you are a researcher, practitioner, or simply curious about technological progress, these trends are redefining the landscape of intelligent machines. Prepare to discover the innovations driving the next wave of AI development. To grasp the scope, consider what defines cs.AI, or computer science, artificial intelligence. This subfield encompasses learning, perception, decision-making, and reasoning. Think of AI as a tree. The roots, algorithms, mathematics, and logic anchor the discipline. The trunk represents practical techniques that bridge foundational theory to real-world AI systems. The branches extend into healthcare, finance, and many other domains, signifying the growing impact of AI. As the roots deepen and the branches spread, the influence of AI continues to expand across society. The first major theme is human-AI collaboration and explainability. In this realm, machines and people operate side by side, each leveraging their respective strengths. For example, one study demonstrates the integration of knowledge graphs and language models to support manufacturing planners through natural language queries. In the medical domain, vision transformers, advanced neural networks for image recognition, are combined with language-based reasoning to achieve explainable diagnostics. This is akin to having an assistant who not only provides answers, but also walks through the reasoning process step by step. The ultimate goal is to develop systems that respond accurately and transparently explain their logic. The second theme centers on robustness, adaptation, and safety. As AI systems are deployed in high-stakes environments with noisy or shifting data, adaptability becomes essential. Researchers have developed models such as Bayesian networks for autonomous triage, as demonstrated by Rusecki et al. These networks are capable of integrating multiple sensor streams to reason under uncertainty. Other studies focus on detecting drift in clinical decision support systems and probing the defenses of large language models to identify vulnerabilities. Bayesian networks, in particular, exemplify reasoning with uncertainty, ensuring AI systems remain resilient in unpredictable conditions. The third theme is conceptual and mathematical reasoning. The goal is to teach AI not merely to imitate patterns, but to think and generalize conceptually. One approach involves reinforcement learning frameworks that supervise models at the concept level, ensuring genuine understanding rather than rote memorization. New benchmarks have been established for formal theorem proving, and models are being developed to monitor the evolving knowledge of students in educational contexts. This is similar to teaching a child the underlying reasons behind mathematical operations, rather than just memorizing answers. Reinforcement learning, or learning via feedback, remains a technical cornerstone in achieving this depth of understanding. Several key findings emerge from this body of research, illustrated through breakthrough examples. The system by Rusecki et al. Raised triage accuracy from 14% to 53% in real-world scenarios. The core framework, concept-oriented reinforcement learning, enables models to achieve true conceptual understanding. Gabliteration, a neural weight modification technique, allows for fine-tuning language models with precision, analogous to tuning a guitar. MIA, a psychology-inspired attack, reveals safety gaps in AI by leveraging the mere exposure effect. NeuroGuard merges vision and language for medical diagnostics, providing transparent, knowledge-grounded explanations for clinical decisions. The standout paper from Ruzecki et al., titled Multimodal Bayesian Network for Robust Assessment of Casualties, marks a new era in autonomous triage, designed for disaster scenarios characterized by chaos, urgency, and incomplete data. This system fuses sensor streams, including computer vision inputs such as trauma and breathing, with expert-guided logic encoded in a Bayesian network. Notably, the system operates effectively without any prior training data. It is engineered for resilience, thriving under uncertainty, and offers explainability by making its reasoning transparent to human responders. The real-world impact of Ruzecki et al.'s system was demonstrated during the DARPA Triage Challenge, which involved 2 missions and a total of 20 casualties. The Bayesian network tripled physiological assessment accuracy compared to vision-only AI systems. Triage accuracy increased from 14% to 53%, while diagnostic coverage improved from 31% to 95%. The system's transparent logic allows responders to see exactly why each recommendation was made. These advances are not merely statistical, they have the potential to translate directly into lives saved during emergency situations. The motivation and legacy behind Ruzecki et al.'s work highlight the importance of every percentage point of accuracy in saving lives. The team overcame significant challenges, such as noisy data streams, real-time operational constraints, and the integration of expert clinical knowledge. The resulting system is tireless, immune to panic, and maintains consistent focus, qualities essential for high-stakes settings. By setting a new standard for robust and interpretable AI, this research inspires future efforts toward transparent, human-guided systems in critical applications. Looking ahead, the future of AI points towards systems that are not only powerful, but also trustworthy, adaptive, and explainable. Neurosymbolic and retrieval-augmented frameworks are expected to scale across domains, combining the strengths of data-driven learning with symbolic reasoning. Efficient and interpretable reinforcement learning strategies will become standard practice. Real-time monitoring and alignment mechanisms will ensure safety and transparency. AI is envisioned as a trusted advisor, constantly learning, reasoning, and supporting human decision-makers in an evolving ecosystem. To conclude, the AI frontier now encompasses systems capable of reasoning through chaos, providing explanations and adapting dynamically. The intersection of deep learning and symbolic logic is advancing, with a continued emphasis on safety and robustness. The next chapter of AI research is being written in laboratories, hospitals, classrooms, and industry settings. Listeners are encouraged to engage with these breakthroughs, question assumptions, and consider how these innovations might impact their own work or daily lives. The frontier of AI is open to everyone. Remain curious and involved. This research summary was synthesized using GPT 4.1 for natural language analysis. Text-to-speech narration is provided by DeepGram, with visual cues generated via OpenAI tools. A human expert reviewed the summary to ensure accuracy and clarity, though minor oversights may persist. Listeners are encouraged to refer to the full papers for comprehensive details. All referenced studies are cited as first author et al. Consult published works for further information. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from the arXiv preprint server. From neural networks to quantum computing, complex research is simplified so you can stay ahead. Whether you are a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.